Hello children, we are going to start with the second chapter in the series of light. The first chapter was related to refraction of light through plane surface, and now it is refraction through a lens. Lens, that means a curved surface, right? So how to define lens? A lens is a transparent refracting medium bounded by either two spherical surfaces or one surface spherical and other surface it can be plane, right? So lenses are basically of two types. We have a convex lens and we have a concave lens. Fine. So we have convex lens. Now it can further it can be of three kinds. We have a biconvex. This is your biconvex, right? Biconvex. Now the two surfaces, they are bulged out, right? Bulged out in the center and it is tapering at the ends. And then we have a plano-convex. This is your plano-convex, right? This is your plano-convex. And then we have a concavo-convex. We have a concavo-convex, right? This is concavo-convex. It is your plano, no, I think it should be plano-convex, fine. Plano-convex. This is concavo-convex. So if you check out biconvex, why I am using the terminology, the two terms are actually defining the two sides of the lens, the two curved surfaces. Bi means two and convex means the two surfaces are convex in nature. Plano-convex, plano and convex, bulged out. Concavo-convex, this is concave and this is convex, bulged out from the middle, right, and tapering at the ends, fine. But here it is thin because we are talking here about the concavo, that's why this is a concave side, whereas this is a convex end. That's why. So these are the three kinds of your convex lens. Now same way we have concave lens as well, and for concave also we on the same pattern we have the three different types for concave lens as well. So on the same pattern I can discuss about, like I have biconvex, I can biconcave. How it's going to be biconcave? It is biconcave. Thick at the ends and thin. It is thin in the middle, thick at the ends. So this is biconcave, right? Now if I say plano-concave, how it's going to be? This is plano and here it's simply going to be concave side. Plano-concave, right? And here this will become concave. And now the next is your convexo-concave. This was concavo-convex. Now I have convexo-concave. This is convexo-concave, right? So I think you must have seen that the two terms are actually defining the two surfaces of the curved surface, right? Now both the concave convex and the convexo concave lenses, they have one surface convex and other surface concave. So if you have seen, I actually drew this diagram in convex again because I actually drew convex and then plane, but it was actually plane and then convex, right? The name, you must have seen how I related the name with the diagram, right? So if you now ask a question, is it convexo-concave and concavo-convex? Isn't it one and the same thing? No, it is not the same thing. Reason being because it is actually going to make a difference from which side light ray is going to enter and from which side the image will be formed, right? So they have one surface convex and other surface concave, but they differ in their shape and action, as I told you. A concavo-convex lens is thicker in the middle and has a converging action on a light beam, While a convexo-concave lens, it is, if you check out, it's going to be thinner, because I think I have made it, it is thinner in the center and it's thick at the ends. Fine. So that's why it has a diverging action here, right? So next we are going to talk about converging and diverging action of a convex lens and a concave lens. Fine. So now we are going to talk about the converging and diverging action of a convex lens and a concave lens. So first of all is convex lens. That is also termed as a converging lens, right? And how it's going to act as a converging lens? We know this is our convex lens. Fine. But actually I can break this convex lens in 3 diagrams. See here. 3 parts can be there. If you see here, this is making 1. This is actually the second part and this is the third part. You know what actually it is making? Can you make out from this figure? This is a prism. This is a prism and this is acting as a glass slab. So this side of the convex lens is acting as a prism. This side is also acting as a prism, but this is acting as a glass slab. Now let's see the action of the light rays that are going to pass through it, right? So if I talk about the glass slab, I know when a ray is perpendicular to the surface, it will pass undeviated. Am I right? So we have done this property in the previous chapter, that when a ray of light is incident on the surface such that it is normal to the surface. When I say normal, I mean to say angle of incidence is 0, right? So it will pass undeviated. Now let's talk about this. A ray that is incident on, on a prism, if I talk about, when a ray is incident here, right? We know that after refraction, it will bend towards base of the prism. Same way, if a ray is passing through the prism, after refraction, it will bend towards the base of the prism. And if you check out, this is the base of this prism, the first prism, and this is the base of the second prism, right? And where they are going to meet? They are going to meet at the focus, right? They are going to meet at the focus. So that's why we say that convex lens has a converging action, because all the rays they are converging to a point, right? Now let's see what happens for a concave lens. If it is a concave lens, then what happens? Concave lens. So we have this concave lens, right? Now what happens? If you check out here, again, I can actually make this prism, I can divide it in 3 different parts. So how it is going to behave? See here again, if you take it to this point, this will be acting as a prism. Again, this will be acting as a prism, right? And this is going to act as a glass slab, right? This part of the concave lens is going to act as a glass slab. So when this is acting as a glass slab, any ray incident perpendicular to glass slab, it will pass undeviated. Am I right? Fine, this we have done. Next is any ray passing through prism. After refraction, it will bend towards base of prism. So this is the base of the prism. It is bending towards the base of the prism. Same way here, a ray again passing through prism. After refraction, it will bend away, towards the base of the prism. It will bend away from head, or I can say it will bend towards the base of the prism. So when you extend it, if you produce it backward, they will meet at a point, that is the second focus, you can say, right? Or the focus. Fine. So this is your diverging action. I can say convex lens is showing diverging action. Concave lens, I think I used the terminology convex. Concave lens is having diverging action, right? So next we are going to start with the few definitions that are related to these concepts, okay? So few definitions. The very first definition that we are going to start is center of curvature. We have center of curvature. Now, what is the center of curvature? Let me define it first of all. A lens has two surfaces actually. As I told you, it is biconvex or biconcave, right? So each surface of the lens is a part of sphere. Let me show you how. If I talk about, now see here, if I draw a circle, right? And if I draw a circle here, right? Can you make out that this is making a convex lens, biconvex, right? So I repeat, a lens has two surfaces and each surface of the lens is a part of the sphere. This surface is also part of the sphere. This surface is also part of the sphere, right? The center of the sphere, whose part is the lens surface, is called center of curvature. Now suppose if I say this is the center of this circle and this is the center of the second circle and first circle, right? So I can say this is the first center of curvature and second center of curvature. This is actually the center of these spheres, right? So the center of the sphere, whose part is the lens surface, is called the center of curvature of that surface of the lens, right? Since two spherical surfaces are there, we have these two spherical surfaces, that's why two center of curvatures are there, right? Next we have, okay, this is, I have shown it for convex lens. What about concave lens? So for concave lens, again consider that two spheres are there, right? Two spheres are there. And now, if you check out, if I again, this is your C1, this is your C2. If you check out this, don't you think so? It is actually giving you a concave lens. This is giving you a concave lens, right? So in this case also, you have, this is convex, concave, fine. So that's why, as I told you, this, okay, I'm passing this line. What this line is termed as principal axis, okay? So again, I'll be talking about the principal axis afterwards. I'll be defining it, right? So this is your center of curvature. As I told you, two center of curvatures are there. But what about principal axis? It is the joining, it is a line joining the center of curvature of two surfaces of the lens. These, right, center of curvatures, a line is joining them. This line will be termed as principal axis, right? Next is, we have radius of curvature. What is radius of curvature? The radius of the sphere, whose part is the lens surface, it is called the radius of curvature of that surface of the lens, right? So if this is considered, I'll use another pen. If this is the center of this lens, right, I'll be denoting it as O. O is termed as optical center. O is your optical center. And here also, right? You know what, bache? Actually, the two surfaces are there. When we'll be talking about lenses, the ray diagrams, for we people, two surfaces are there. So refraction actually should occur at two surfaces, right? First from rarer to denser and then from denser to rarer. And same way here. But the thing is, like we have our convenient, the three rules they give it to you to draw the ray diagrams. Likewise, we have for convenience, we have done that the bending of the ray, the refraction will not be happening at the two surfaces, will be actually showing it exactly from the center. I'll be again taking this part when I'll be discussing about the ray diagrams. Okay, so first of all, let's just concentrate on the definitions only. So this is your optical center, right? The distance between C1 and O, or O and C2. And same way here, this will be termed as radius of curvature, right? This will be termed as radius of curvature. We have Radius of curvature. Okay, so we have done three definitions. This is the third. First one was center of curvature. Second is principal axis. And third we did radius of curvature, right? So now let's proceed with further. Now let's redefine optical center. Optical center is of a thin lens, you can say, because when I'm drawing diagram here, I may represent it very big, but otherwise optical center of a thin lens is the point on the principal axis, thin, this is a point, right, on the principal axis of the lens, such that a ray of light directed towards it passes undeviated. This actually we'll be doing when we'll be discussing about the ray diagrams, okay? So but I hope so you have, it's just like I can represent it. It's just like, suppose a ray is there incident at this point of the lens, right? It will pass at this point and it will pass undeviated. This is what they want to tell you. Same way, if I'm talking about this side, this lens, concave lens, a ray, and it will pass undeviated. And how come undeviated? Even though the refracting surfaces are there. So this is what a special characteristic of this particular point we are talking, right? The optical center, at this particular point, the ray will pass undeviated, right? So next is your principal foci. So what is this principal foci? Now we have seen, as I told you, these are the two surfaces of the lens, and actually light can enter through this. Light can be incident like it is here, and it can be actually incident this way also, isn't it? It may be incident this way also. So actually two surfaces are there from where light can enter, right? Therefore a lens has two principal foci, one on either side of the lens, and these are actually termed as first focal point or second focal point. So if the medium is same on the both sides of the lens, then two foci, they are situated at equal distance from the optical center. Like here, I can draw the diagram again. Let me draw it again. I'll show it to you. Like suppose I'm talking about this lens. A convex lens is there, right? So this is your principal axis. This is your optical center, right? And now light can enter through this phase as well as through this phase, right? So as I told you, we have two principal foci, and or we can always say first focal point or second focal point. So if I talk about convex lens, what is the first focal point for a convex lens? The first focal point is the point F1. This is the point F1 on the principal axis of the lens, such that the rays of light coming from it, right, coming from it, after refraction, it becomes parallel to it. After refraction, it becomes parallel to it. It means principal axis here, okay? And as I told you, for convention, we have taken that the bending, it actually occurs from the center of this lens, right? So it will become parallel to the principal axis. So this is your first focal point of convex lens. And if I talk about concave lens, again, for concave lens, the first focal point is the point F1 on the principal axis of the lens, such that the incident rays of light, let me draw it first of all. So this is your concave lens, this is your principal axis, and this is your optical center, right? Incident rays of light appearing to meet at it after refraction of the lens, from the lens, it becomes parallel to the principal axis of the lens. So how is it so? Like here, this is your first principal focus, right? And now the rays are coming, fine, from your first, what you say, focal point for concave, right? So we have the ray is coming here, from here. They will appear to meet at this point. They will appear to meet at this point, right? But at this point they become parallel to the surface. They simply appear to meet at this point. Fine. Next we have second focal point. So what is your second focal point? I can use the same diagram to define second focal point as well, right? So in convex lens, if I talk about second focal point, for the second focal point in convex lens, it's a point on the principal axis of the lens such that the rays of light incident parallel to the principal axis after refraction. After refraction, they meet here. Okay. This is. What was the first? From first, rays were originating. And in this, on the second, the rays that were parallel to principal axis, they will meet after refraction, right? And what about the concave lens? What happens in concave lens? Again, for concave lens, this is your concave lens, right? And this is your principal axis, this is your optical center, the center. We divide the lens in two parts, right? So, the rays are parallel to principal axis. After refraction, they are going to bend towards base of prism. It means diverging action, isn't it? But they appear to meet. If you extend, they will appear to meet at this point. So this is your second focal point, right? For concave lens, okay. So what about focal length? Focal length is the distance between optical center and the focus. So if I say first focal length, it will be the distance between optical center and the first focal point. It was F1 here. And if I talk about second, it will be distance between optical center and second focal point, right? This is the, second focal length and first focal length. Now, some important points we need to remember. If the medium on both sides of lens is same, then the first and second focal length, they are going to be equal, right? And a convex lens has a real focus, whereas a concave lens has a virtual focus. Okay, so we need to remember these important points. And next is the focal point of a lens. It depends upon two factors, right? It depends upon two factors. I can write here. The focal length, it depends upon two factors. First is the refractive index of the material of lens relative to the surrounding medium where we have kept the lens, right? And if the lens is placed in water instead of air, its focal length will increase. Its focal length will increase. It means if there is going to be, what about the refractive index of water? It is more or less? It's more, right? So the refractive, as the refractive index is going to be more, the focal length is also going to be more. It means they are directly proportional to the refractive index. Focal length is directly proportional to the refractive index. And second is the radii of curvature of the two surfaces of length. A thick lens has less focal length than that of a thin lens of same material. Fine. So if the part of the lens is covered, okay, suppose I have a lens and I cover it. Suppose this is my lens and I cover half of the part, right? So what is going to change? Its action is going to change? Its focal length, it will remain unchanged. Only part that is going to change is the intensity of light that's going to pass through the lens, right? See here, if I'm going to cover it, right, only focal length is going to change, but the intensity, see, if I have a full part, how much light is going to focus on it? But if half part is going to be covered, it means the intensity of light is going to reduce. It's going to half, right? So the intensity of light is going to reduce, but the focal length is going to remain same. Or I can say there is not going to be change in the position, size and nature of the image formed by it. Okay, it will not change. It is the only intensity of the light that is going to change, the intensity of the image. the image may seem to be blurred. It will not be as bright, right? So this is the meaning of this sentence. So I hope so now you can differentiate between a convex lens and concave lens. Convex lens is thick in the middle and thin at its periphery, right? As I drew, I'm just going to draw it again. Convex, it is your convex, and concave, right? So it is thick in the middle and thin at the periphery, whereas in concave lens, it is thin in the middle and thick at its periphery. It has converging action, whereas concave has a diverging action. And as I told you, for regarding focus, convex has a real focus, whereas concave lens has a virtual focus. Okay, so this is the first video regarding the curved surfaces, light through the curved surfaces, and this is the introduction, the basic terminologies we have covered in this video. In the next video, we are going to talk about the ray diagrams of convex and concave lens, and then one more topic related to power is also there. Okay, so watch it carefully, go through the terminologies carefully, and just be careful that you remember these terms, because we'll be using these terms in the ray diagrams. Okay, till then, bye bye, God bless you.